Welcome to One Question at a Time, the SAT series. Question number 29. In the figure above, the circle with the center O has PQ tangent to it at P. If M, the measurement of the angles PQO equal 50 degrees, find the ratio of the shaded area to the area of the circle. So we have something to review in these questions, and I think we lacking of the choices in this one, so let's make it up. So choice A is going to be 2/9. Choice B is going to be 1/9, and then choice C, that's going to be 2/5, and choice D is will be 3/5. So we have the center with the tangents. Okay, so tangent at P. So this one, you see that BQ, that the tangent line to the circle, which is it would be perpendicular at P with the, so PQ perpendicular to PB. Okay, so this one, that perpendiculars, okay, 90 degree. This is 90 degree. Okay, the tangent, that's what tangent mean. The measurements, so the M with the angle like that is called measurements. So the angles is 50 degree. So PQO is 50 degree. The ratio of the sected areas to the area of the circle. So we have to know that the question mark in this case, the unknown in this case, is what they're asking is, they're asking for the ratio, or they may ask for the previous question is the probability of landing on shaded area, right? So we have shaded area over the area of a circle, of the circle, right? So we may have to remember the area of the circle. What area of the circle with the radius r? That is pi r square, right? Then do we remember the area of the sector? So each piece like this we call a sector, right? And we have two pieces, and that two piece is the same, like it equal areas. So let's call this is the area including A, right? I call part A, and this one I call part B. So that the area label A is equal the area label P. Why? Because we see that we have the same radius, R right here, right? And also the angle, the opposite angles right here, the purple one, the opposite angle inside and pass through the origin of the center of the circle O. So that too is the same angles. The purple angles, let's say the purple angles is the same, right? And that bubble angles right there are like the POQ. That angle is 40 degrees. How we know? We have to remember all of the angle inside of the right triangle, right? We have the right triangles, or just triangle general. We will have angle P is 90 degree, and angle Q is 50 degree, and angle O, that is the bubble one, right? This is 90 at 50 at O equal 180. So we can find O. O in this case is the POQ. Okay, and that one will be 180. We subtract 90. We subtract 50. Then we have 40. That equal 40 degree. Okay. Okay, so we go back to our formula of area of a sector, right? So it will be I will remind that it will be the sector. It's just a part with R right here. Okay, and then angle theta. So it will be equal to 1/2. This is the formula, okay? R squared theta. If this theta is in radian, okay? And it will be equal to theta divide 360 times pi R square. If the theta in this case let's say if theta in this case will be the degree. Radian. Okay. So you have to memorize those three formulas, right? So 4 totals. 1, 2, 3, 4 to be using and solve for these questions. But remember, we can also thinking about the part over the whole, right? But instead of memorize those formulas, of course, if we know the formulas, we find out the numbers, we still can do it, but it's not fast. It's consume our time a lot. So instead of that, we will thinking about the angle only, right? We're only taking the ratio of the angle of shaded area compared to the area of the circle. The whole circle, how many? What is the angle of the whole circle? The angle of the whole circle, that will be 360. One part of the shaded area is 40. That's the purple angle we just labeled. That is the sector. Okay, one piece is 40 degrees, but we have 2 of them. So we multiply by 2. So to make it easy, we will have the ratio that equal 2 times 40 degree over 360 degree. Now let's just rewrite it one more time. So 2 times 40 over 360. We can say the degree is cancelled, so the unit cancel. Okay, we're working out with the number only. Why we not do the multiplication between 2 and 40 first? Because we want to simplify these fractions, so we break it down into 2 times 4 times 10, and then 360 will be 4 times 9 times 10. Wherever we see number 36, that is 4 times 9. If we see any 0 at the unit digits right here, we're thinking about multiply by 10. That's the power of 10. So top and bottom we have the factor, common factor 10. We cancel it. We left with 2 over 9. So this is the correct answer, A. How about if we using the formula, okay? So we will have to find out what is, let's do the radius of the circle square times pi, that is the whole area of the circle. And then because we find out the degree, so we use these formulas for the sector. Okay, but we have to multiply by 2 because we have 2 sectors with the same area. Okay, so we multiply this one by 2. That is our part. Okay, so let's do this. This is number 1. The second one is we use the formula method. So we have to multiply by theta over 360 pi times pi r squared over the area of the circle, which is pi r squared. And theta, in this case, we already find out is 40 degree. That is our theta. Okay. So we cancel the pi, we cancel the r squared. This one left with 1, but anything divided by 1 is that thing. So we have 2 times 40 over 360 over 1, which is 2 times 40 over 360, which is 2 times 4 times 10 over 36 times 10, 2 times 4 over 36. That's the same thing as 2 times 1 over 9. That is 2 over 9. Thank you for participating in this series. See you next time.